So, welcome to tonight's robotics meeting. We have our wonderful guest tonight with us, Andra Kie. And, well, I'll turn it over to her now.
Well, thank you so much. I'm doing the usual battle to get slides up without it being too disruptive.
Uh,
And
while you're doing that, can you tell us about yourself?
yes, indeed. So you might detect from the accent that I'm actually Australian, but I moved over to the Bay Area at the start of 2011. And I was finishing off a master's in human robot interaction. And I was particularly fascinated not just by one-on-one interaction, but the broader economics and social interactions of robotics. Things like, are we building inclusive robotics? Is everybody going to have the right access to robotics? Who's making the decisions about it? Who's funding robots once we hit that in-between research, entering the real world? What impact is that going to have on the sorts of robotics that we get? And, how do we get the sort of robots that are going to be most valuable in the world? So those were really the bigger questions that interested me. And I thought, there's a lot of robotics that is happening in Silicon Valley, but no one's talking about it, barring Willow Garage. And Willow Garage, it was like that was going to be my dream place to work. I was reading the publications, I was fascinated by what was happening, and I was fascinated by the idea that we were going to start to see robotics startups, that there was going to be a new wave of robotics coming because the technological drivers were becoming more and more affordable. Now, I happened to be talking at a robotics conference about that to Steve Cousins and Rich Mahoney. And I was saying, why doesn't anybody know that there's robotics in Silicon Valley? And they said, well, we've just formed an organization, Silicon Valley Robotics, because we want to let the rest of the world know that there is a lot of robotics here. And we want to increase the investment into robotics because really there was almost no venture investment in robotics globally in 2010, practically none. And I have to say, in general, the investment community wasn't terribly interested. But I ended up working as the managing director of Silicon Valley Robotics. I officially formed the organization, and really our first 5-year plan was to increase the awareness of robotics in Silicon Valley and to increase investment. And at a certain point, by 2015, it was clear that those things were happening. And we've always been a grassroots, member-driven organization. So I've been very interested in, well, what's our next 5-year plan? What do we need to do next to facilitate the commercialization of innovative robotics? And I stress innovative robotics because once you've commercialized and you're just repeating the same old pattern, I mean, that's not interesting and you don't need help with that. But taking a completely new category of device, you are facing a lot of issues with growing that into the real world. And so one of the things that we've done for the last 5 years has been to increase the connections that we're making between the robotics industry or robotics startups and not just academia, but particularly the various market sectors that are emerging as the real growth areas for robotics. So logistics is one of them, health is another, retail is one, and recently we've launched the Construction Robotics Forum 2-3 years ago because that's a growing area. And we are launching forums in different topic areas. I'd like to launch one in agriculture. Well, actually, we've had a number of agriculture events for a few years, so we've more or less launched something there. But I'd like to do something looking at marine robotics next, and then, of course, space robotics, which is having a wonderful moment. And now I'm starting to think, as well as launching these more topic-based forums, there could be a good overlap with what's happening in research if we do some that are focusing on various technical areas of robotics. But we're a very small organization, so it can take us a while to launch all of the things that I would like to do. One of the things that I'm most pleased about is that I went ahead and launched Women in Robotics, even though at the time my board of directors was hesitant to do something that, well, nobody quite knew what that was going to mean or what value that would have. Whereas I think in hindsight, everybody is very supportive and appreciates the fact that we've been focusing on diversity in robotics. And just last year, we have a regular event, Society Robots and Us, which started at the start of the COVID pandemic, because we wanted to ask the question, what is technology or technologists and engineers doing to address this? And how do people find out about this? And so we've had a range, we connected at that point with Open Source Medical Supplies, which was run by a roboticist, Kim Cavalcanti, who you might know from Megabots. And we connected with Helpful Engineering. And we worked to be a bit of a connector between, say, you've probably heard of projects like NASA built a something that helps breathe, and I can't remember the name of it right now, but you had a lot of individuals that were redesigning medical equipment, and there has been an incredible 10-year fast forward of innovation in this space, because there were a lot of things that could be improved on that weren't, because people were all like, yeah, okay, well, this is what we do for swabs. This is, the swabs that you buy. But due to the shortage of swabs, for example, there were 3D printed swabs. There were questions, like universities were calling us up and saying, is there a robot that we can use to put together a testing kit or to do other things? So that's how our series started. But last year we broadened into just talking about society and robots. And we had an event on robots and racism with Ayana Howard and Chad Jenkins and a few others. And that led to the start of the Black in Robotics organization, which you can probably, well, I hope you've heard of it. It's had some write-ups in Spectrum and in some other places. And it's really good to see these things start to happen. And look, that's a lot about me and Silicon Valley Robotics, but I think it gives you an idea of where I'm coming from. And effectively, I'm building an ecosystem. And the part that I find fascinating about ecosystem building is that we need to include everybody as much as possible. And so that's something that I am always looking at. And I hope that I'm screen sharing. I'm just going to flip over to, here we go, full presentation mode. I gave this presentation recently, and it's a more specialized one than I would sometimes do, but there's some key concepts that I want to raise. And this one is focused on robotics for science and conservation, which I thought you might find pretty cool. And I want to start with some of these, what I would call like key concepts, because very often people are very familiar with their area of robotics and they don't have the opportunity to see the big picture. Whereas I'm really focusing on the big picture. You've probably heard the robots are good for the dirty, dull, and dangerous jobs, the 3Ds of robotics. I call it.
I'm sorry, Andra.
Mm-hmm.
You're sharing the presenter's view. I don't know if you can. There you go. Perfect. Thank you.
Yeah. It was just a little bit of a lag for it swapping over. Now, are you seeing the full screen or is it cut off on the side?
Full screen presentation is good now.
Yes.
Yeah, it's good.
Are you seeing the writing at the top?
No, that's cut off.
Yeah, okay, let me swap displays because it's showing on the wrong screen on my laptop. That should be better.
There you go.
Great. Okay, so I call it the 4Ds of robotics because these robots are dumb. And I refer to this as robotics 1.0 to help people understand that we've had a sea change in robotics that is far more than just more robots. We've had 50 years of robotics 1.0, and they're dirty, dull, and dangerous robots, dumb robots. And they're doing dirty, dull, and dangerous jobs, quite dumb, repetitive jobs. In fact, these robots don't meet the standards for what is a robot now. They are just not reprogrammable enough in many cases, or they're not reprogrammable without a lot of expense and effort. 50% of the robotics 1.0 industry is still doing nothing but welding automobile bodies. That was the first thing these robot arms were put to work doing, and that is still 50% of what people talk about when they talk about the robotics industry. That's not the robotics industry that I know or see. And this is why I'm saying I call it robotics 1.0 to really emphasize that things are a lot different. Now, it's not that robotics 1.0 is not important. It is a large chunk of what's happening in robotics. It's worth approximately 48 billion last year, which was approximately 18 billion for the robots alone, and that's 48 billion cumulatively when you bundle it together with the software and the servicing, which is usually how these robots are sold, as like a full package. And what we're in, and we have been since around the start of 2010, is the robotics 2.0 era, which is quite a paradigm shift. And we will move to a different era of robotics, but I don't know exactly when. It might be 50 years from now. And one of the issues that we find is that you will see research videos widely promoted in media, and it can be tricky to know which of these are really robotics 3.0, nowhere near real world yet, and which one of these are actually rippling out into the real world. So there's a couple of criteria that robotics 2.0 has as well. And one of them is inspired through the growth of the self-driving car. Most cars these days are robots. In fact, pretty much everything from 2008 qualifies as a robot, at least within parts of the systems. We don't need to have level 5 autonomy in cars to have robotic systems. Most roboticists that I know have spent some time working on autonomous vehicles, or still do. And it's not simply self-driving vehicles, of course. It's autonomous vehicles across the board. Now, robotics 2.0, you don't measure it by looking at revenue because many of these companies are pre-revenue. And that's why it doesn't appear in a lot of the robotics industry discussions. It's simply not on their horizon yet. But if you measure funding, investment into robotics, then you can get a much clearer idea of what the shape of robotics 2.0 is, because right now it is largely investment funded rather than revenue, although that will shift over the next 5 to 10 years. Now, these are categories that the robotics industry, the robotics 1.0 industry, calls other and unspecified. They're growing exponentially each year. And in 2020, it was a total globally of $19 billion in investment. So you can see that the investment in the robotics industry is actually greater than the pure revenue from the old robotics industry. And that's just a sign of how much things have changed in the last 10 years. Dr. Gil Pratt, who is now managing Toyota Robotic Research Institute, who when he was the head of the DARPA Robotics Challenge, he said, I think we're having a Cambrian explosion in robotics. And I think he's quite right. And I think he's particularly right because if you really look at Robotics 1.0, it's primarily stationary in many ways. Robotics today is mobile in the sense that it has the ability to navigate. And the Cambrian explosion biologically happened because of vision. Small little worms and tiny organisms developed a visual sensor. And that allowed them to chase their food, not just squirm their way in and out of patches of food. They were able to direct themselves towards food. And often that meant other organisms, so they also started to run away. That led to a really rapid evolutionary period where the basis of every single phyla or category of biological life emerged in a very short time frame, comparatively speaking. And I think that this GIF, I love it. I think it expresses both the biological Cambrian explosion and the robotic Cambrian explosion, because you're probably all familiar with robot vacuum cleaners. And you know that the original Roomba vacuum cleaner was very stupid. It was modeled on insect behavior with Rodney Brooks's subsumption architecture, and it didn't map. It didn't have sensors other than it had a bump sensor to detect when it hit walls. It had a little dirt sensor so that it would circle when it hit a particularly dirty patch, and it might have had a edge of stair detector. But really, I had Roombas back in Australia, loved them, and they were always a talking point at dinner parties, and people didn't believe that it wasn't mapping. We just had this anthropocentric bias where we're like, but it has to know where it's going. And really it didn't. But of course, robot vacuum cleaners have changed. They're now 28% of all vacuum cleaners sold. And every major vacuum cleaner company has a robot vacuum cleaner in their product lineup. They've become that significant. And so there's been a bit of an arms race, and robot vacuum cleaners, like self-driving cars, have incorporated sensors. And this mass production or mass utilization of sensors has triggered competition in both the camera and the LiDAR spaces, and has seen a rapid reduction in the price of sensors. At the same time, of course, we've had a reduction in the price of computing, and all these things really lead together in a storm of things that allow robots to navigate in real time in the real world. And whether it's a robot arm or whether it's a mobile robot, the key feature of Robotics 2.0 is that it navigates in the real world, with real-time decisions. And that allows for collaborative robot arms that are safe to operate around people, because the robot arms are aware, comparatively aware, of what's happening around them. And so I call this the 4 S's of Robotics 2.0, smarter robots with sensors, which makes them safer. But at least in these initial days of the commercial rollout of Robotics 2.0, single tasks, we have seen a real shift from people attempting to launch more general purpose robot platforms on the market while they're still trying to work out what people are going to like. So for example, you can see one of the shelf scanning inventory robots on the bottom screen. And a lot of these companies, like Fellow Robots was one of the first to launch a shelf scanning robot, but it also acted as a guide. It also acted as a part scanner. It also acted as a greeter. And it was doing a lot of different things as they were experimenting in the Lowe's Hardware Innovation Labs. What propelled an increase in the uptake of inventory robots, and of course you've got Simbi Robotics, you've got Bossa Nova Robotics, you've got Fellow Robots, and now you've got a lot of, you have inventory companies building robots. You have mobile robot companies like Fetch Robotics partnering with an inventory company so that they can do inventory robots. It is now a thing, inventory scanning robots. And that was really a beachhead market. It was the one task that made a significant difference to the operating costs for a retailer. Now that those robots are in the store, I think we will start to see a variety of tasks. But when you're trying to get into the market, offering a variety of things turns out not to be the best strategy. So at the moment, I have S for simple tasks and single tasks, because I really don't want people to be thinking that robots are general purpose. That's, I think, a robotics 3.0 thing. And in fact, let's move along. Since this Cambrian explosion and effectively innovation arms race in the reduction of cost of computation, of power to a lesser extent, and of sensors, we've seen low-cost robots. You can get more or less a whole robot stack for less than $10,000. If you look at, for example, the $2,000 autonomous mobile robot base from Ubiquity Robotics, with the, it was 6,000 when I was talking to them. I think it's more like 7,500, and it might be bundled with other things. But the Eve, no, this is Automata, which is based in the UK, but you have Haddington Dynamics, who are based in Las Vegas, that Ocado just acquired. They were offering you a robot arm for about $7,500. And there's a number of other companies that have launched in the last 2-3 years. Verdict is still out on the reliability from an industrial perspective for some of them, but you can definitely get robot arms for less than $10,000. And it used to be that the end effector cost you $25,000 as well as the arm, whereas you have companies like Sake Robotics that have a very effective 3D printed gripper for $2,500. And I think we are seeing a lot of innovation in this space, primarily through 3D printing. But we saw a real flurry in the last 10 years of, say, soft robotics grippers, and grippers like the jamming gripper from Empire Robotics, which, if people juggle, it was like a juggling ball. It was like a globe that was full of something like rice grains, which when you pull vacuum through it, it deforms around an object that can be a flat key, for example, something terribly difficult to pick up otherwise. And so that is another innovative grip. Or you have something like the electrostatic adhesion that Grabbit used, that came out of SRI International. So we've seen a lot of innovation as well in the gripping space. It hasn't percolated the market as rapidly as I thought it would, but I think it's because it has to go on the end of an arm. And the arm market is still dominated by the Robotics 1.0 companies. The other thing that has happened, in fact, released in 2010, is Robot Operating System. And Robot Operating System, or ROS, provides you with the plumbing and the tools to really increase your capabilities to build on the work that others have done and do it repeatably and do it over and over again. And we've seen that the downloads of ROS have gone up hugely. When talking to startups, what I've noticed is that it went from just the startups that were involved in open robotics and Willow Garage using ROS to almost 100% of startups using ROS, not necessarily in production code, but in getting off the ground And so the impact that Ross has had on the growth of the commercialization of robotics is immense. And I think this leads to a couple of interesting things. Robots are getting vastly more usable, and this is on the piggyback of smartphones and tablets. And any of us who have children or nieces and nephews or have seen toddlers in coffee shops, you know that the average baby can operate a tablet, no problems. So we've really just been training the next generation of robot operators. Yes, we do need to do more education in robotics, but it isn't going to be a case where there are the people with degrees that can work on robots, and then there's the rest of the world. No, it's not going to be that case at all. And in fact, robotics is increasing the number of jobs that are out there around operating robots incredibly. All of us who play with robots know that robots break down quite frequently, and they need to get often moved, pulled out of corners, helped across the road. There are a lot of jobs for robot wranglers out there, and this literally is an advertising term. Now there are terms like traffic controllers and flow controllers. Amazon calls it a flow controller, helping make sure that the robots are all flowing in the right direction, not getting stuck in places and so forth. It has broader responsibilities as well, but you can see that for every robot that's out there at the moment, you need at least one handler. And when we're reducing it down to one handler per 4 robots, then I think we're starting to be quite effective commercially. But let's talk about robots for conservation and science. And one of the things that I loved watching was the growth of the open ROV community. And indeed, we built some versions of that. I think the Office of Naval Research had launched a school kit, an educational kit for a remote operated underwater vehicle. And of course, these open ROVs were largely remote operated, but they introduced the world to this idea that you could get your hands on something else. Like the drone community had grown hugely around 2013, 2014 on the backs of the growth of the Ardu pilot and communities. And this rippled out literally into underwater robotics, which I thought introduced a lot of, because these devices were affordable. One of the beautiful things about this is it introduced people to robots who weren't interested in them as robots. They were interested in them as tools for their research or exploration. And since then, the use of robots for conservation and science has continued to increase. This is an Australian project. It was called COTSBOT, and it was called COTSBOT because of the crown of thorns starfish and COTS. The crown of thorns starfish has decimated the coral reefs, the Great Barrier Reef, one of the world's 7 wonders. And I think something like 50% of the reef has been killed off because of crown of thorns starfish. This was a university project from about 2014. It is an underwater robot that launches like a spear gun to the crown of thorns starfish. And I think you can see one of the quite large Ripley, no, that one's not crown of thorns. Anyway, crown of thorns starfish are quite large. There's quite a lot of them on the reef. They have a lot of arms. And one of the reasons that this was possible is some parallel research discovered that a very simple solution was actually a strong toxin for the crown of thorns starfish, but didn't harm anything else. And what's happened since then is this is version 2 of the COTSBOT. It's still largely grant funded, but this is now a commercial version. It is much smaller. It is much more robust. And as they realized, the actual hotspot had to be operated by experts. This is the ranger bot, and that can be operated by fishers, scientists, by anybody. And now we're starting to see new projects emerge. So it's called, also this one is called Larval Bot, and it's harvesting coral larvae. So something like, it can carry about 1.5 million coral larvae. And that means that just 2 or 3 of these robots, like the healthy corals, release hundreds of millions of larvae. And just 2 or 3 of these robots collecting the larvae can spread it over thousands of square meters of damaged coral per hour per robot. So we're looking at a lot of reef regeneration, which is critically important in this era of temperature change as well, because that's another significant contributor to reef die-out and coral bleaching. You've probably seen the wonderful, beautiful mermaid robot from Stanford. It's called Ocean One. And in 2016, its very first voyage was in the Mediterranean, recovering treasures from the shipwreck of Louis XIV. And it is a pretty complex robot because it provides a lot of haptic feedback for the operator up in the ship. So Osama Khatib, who was operating it for the first mission, was able to recover a vase from the shipwreck and pick it up with the robot without breaking it and bring it all the way to the surface. So I wanted to mention the impact of robots in archaeology, although you're probably familiar with the work of James Cameron's team as well, which is very cool. One of the startups that I met back in 2015 originally, when it was just an idea and a prototype, was Aqua AI. And they had a vision of saving the world's oceans and focusing on aquaculture initially. They built a fish robot, and well, they built the fish robot for any sort of research in the oceans under this idea that a fish robot was going to be less disturbing than a robot. Now that actually turns out to be true. I'm actually showing 2 different robot fish here. This one, the one on the right that's white, is a Kickstarter, but I liked having a moving robot in there. The yellow and black one was originally designed like a clownfish, and it is now operating in salmon farms in Norway, and the company is spreading out across the world. It looks like a clownfish because the salmon farmers have found that this upsets the fish hardly at all. So they can have constant real-time monitoring of the conditions where the fish are. Otherwise, you're really stuck in this situation where you can see the fish when you put them in, and you can see what's happening with the fish when you take them out. But what's happening in the water, which is open to, well, might be fenced, but is still open to the rest of the water. What is actually happening in real time is still quite a mystery, but the fish robots assimilate really well into the salmon streams, but they asked for a clownfish coloration so that they could tell it apart more easily. The human operators could recognize where the robot fish was more easily. And I think they've really been going great guns. I think they've just got, they've gone from seed funding to Series A funding. And it takes a while. I have to say, getting your startup, a robot startup that's doing something completely new, is a slow process. but it is happening twice as rapidly today as it used to happen. I mapped the length of time it takes startups to get off the ground in robotics, and up till about 2012, the average duration was 8 to 10 years. Now I have seen robotic startups launch in 2 to 3 years. And the average time to get your Series A funding is 4 to 5 years. That's half or twice the pace at which it used to happen. At least in the Silicon Valley Bay Area. If you're somewhere else, then you are probably more grant reliant and or more regional funding reliant. And that is both a good and a bad thing. It's, anyway, here is another very cool project. We talked about Roombas before. This is Colin Engel's project, RISE or robotsize.org, RSE, and it's a lionfish catcher. Lionfishes are an invasive species in a lot of areas, I think particularly around the Caribbean. It's currently testing in Bermuda, and it's a human created problem, bringing invasive species into areas that have no natural defenses against them. But one of the cool things about the way this has been designed is the lionfish is zapped. Those two paddles that you can see there deliver an electric shock to the lionfish, and then it's captured in that container, with the idea being that fishermen can use this device to harvest lionfish and sell the fish to restaurants. And that creates even more motivation to catch lionfish. And I think that's important, really. We can't insert first world solutions into second world locations. We have to make sure that the community that is where robots are deployed has benefit from the robots. And I said second world because that is another thing that has significantly changed that we're often not aware of. Most of the world is now developing nation. And so the phrases first world, third world are no longer politically correct. And instead the phrase is developing and developed. And if you look at the quality of life globally, then most developing countries have very similar quality of life to the US, just probably quite different cost of living in terms of sum total dollars. But things are frequently done differently. Infrastructures are different. And for example, there's a lot of use of, potentially there's a lot of use of drones in Africa because there is far less in the way of road infrastructure that's robust and can survive rainstorms and other, primarily rainstorms and flood outs and so forth. So for quite a while, there was a competition to develop a cargo carrying drone that would be able to replace a donkey, because donkeys are more effective than trucks in many, many regions because of the lack of road infrastructure. So you have to think about your local conditions and understand how best to complement what exists. I put Conservify in because they've launched a set of field kits, because one of the other issues is providing a full stack solution. A drone on its own is not that useful to a scientist. But if it's been designed to carry a standardized testing kit, then you've provided something far more useful. So it's actually this provision of the test kit that is the valuable part now. And I think that's a really interesting way of looking at what's happening in robotics. How are people customizing a payload and an application? Drones for Good is another of the projects largely sponsored by Drone Deploy, but that's one of the most widely spread uses of drones for good out there. And what is interesting here is you can see one of these shows the mapping in the aftermath of the Santa Rosa fires and the campfires. Some of these show post-earthquake in Mexico City. And some of these are fire and burn management tools. And so, for example, in Australia, drones are being used for back burning management. Particularly, there is a new, let's see if we're getting onto that slide next. Yes. There is a new program in Australia called Indigenous Rangers, where the looking after the land is the job of the people that traditionally look after the land. And this program is expanding a lot. And what is happening is that the traditional land owners are utilizing technology to help them. And one of the big projects, Microsoft has been supporting it with their AI, is looking after turtles, detecting where turtle nests are and being able to help protect them over that very delicate journey into the water where they are frequently picked off by predators, or monitoring for signs of carpet snake incursion or any of the other predators that eat eggs from nests. The other thing is managing fire burns. And it turns out that Australia has a far more diverse landscape than it would do if we let it alone to go bush, which is, it's just discovering one of those misconceptions. Scientists and historians and conservationists thought the best thing to protect the natural landscape in Australia would be to shut it off, keep people out of it, keep people away from it and let it return to its natural condition. And they've discovered that the natural condition becomes taken over by only one or two species, not the diverse, even if it's desert, it's been a diverse landscape that we're actually used to. And it turns out that the Australian Indigenous people have for about 60,000 years been practicing burning parts of the landscape to open areas up for various new growths. And by doing that, they've encouraged a much broader range of cohabitation from other species. So now there's a turnaround in thinking about how to manage the natural landscape in Australia. And again, it's led to the launching of the Indigenous Ranger programs and the Indigenous Protected Areas program, where again, as said, the Indigenous people are in control of how the land is looked after. And they're using technology to do that. So I do really think that that is a great opportunity for us to empower Indigenous communities with technology. It's a problem that is not solved, that's barely started, but I'm quite inspired by what's happening here. There's another group called We Robotics that is doing a lot of local technology labs, and they've been growing like topsy for the last 2-3 years. They were headquartered in Zurich, but they're spreading out across the world and tackling all sorts of projects that are relevant to the local community, whether it's mosquito programs, pest control, or mapping, or knowledge base work. It's what the local community wants. And effectively, they're just bringing in some knowledge and some access to technology and providing teaching hubs rather than, so I think they call it, what are they calling it? I might have had two of those slides. We'll move along. Oh yeah, sorry. We're starting to see actual release from drones too, which is an interesting thing. But I think I've covered everything. I just wanted to say the takeaways from this are navigation and information is, firstly, we now have robots that are capable of navigation. They don't all need to be remote operated, at least partially. They are able to be safer in operation around people, and they're far more affordable. Information is the most significant payload that robots can provide initially. But we're starting to move into very small scale manipulation. So something like a release program, some ladybirds or something else, not necessarily something that's heavyweight, at least not for aerial robots. But of course, something like the Ubiquity mobile robot base can carry over 100 kilos and run for 8 hours on its batteries. So mobile robots are much more adept at weight bearing. And next up, robotics 3.0. Don't quite know what it is. That's a lot of research videos, but some of the research videos you've been seeing, if it has the characteristics of robotics 2.0, then that is actually commercializing in the world right now. There's you probably recollect the phrase that William Gibson made popular in an interview with The Economist in 2003. He said, "The future is already here. It's just not evenly distributed yet." And that is certainly what's happening in robotics. And I think a key thing for robotics 3.0 will be single tasks becoming system-wide tasks, multi-agent robotics. This is my thoughts about what it's going to look like. The 4 M's of robotics 3.0: multitasking, multi-agent, and I'm bending the analogy a little bit, but emotive, as in able to contextualize a social interaction and respond appropriately. And morphing, soft robotics, shape-changing robots. That's something that is in the research lab and is very cool. Oh, and of course, I'm using the Big Hero 6 slides because it's my favorite robot documentary. And it was informed by a lot of the robot labs in the Bay Area. As you can see here, this is the micro factory from SRI International. And they can do multiple robot coordination. And this one is the Charm Lab, Alison Okamura's lab at Stanford, working on soft robots capable of a range of tasks. They're capable of performing manipulations in the real world now. And this is a couple of years old, these videos. So it's undoubtedly progressed, but they're still unlikely to be commercialized for quite some time. But I think that's where the future is going to be very interesting. And now it's time for questions. And I'm sure we are going to get some great questions.
Actually, I've got to admit, you touched on everything I'm excited about when it comes to robotics. Cultural aspect, environmental, and soft robotics. With soft robotics, what do you see as a future or even commercial potential for that one?
Well, the original development of soft robotics was some DARPA grants for battlefield work. And I think we're going to continue to see medical applications, we're seeing it most in exoskeletons, potentially prosthetics, because it's much more affordable, and anything that's touching on the human body, it's ideal if it's soft. And yes, Zipline is also working in the United States as well, doing medical deliveries now. So that's one of the significant changes. They've taken what they've learned in Africa and they're working globally, but they're also working in the United States.
The advent of rescue robotics in hazardous areas is one that was being looked at extremely closely by the military, but I don't know. I haven't seen any releases on that recently. Have you heard anything about that?
Rescue robotics?
Yes.
Robin Murphy wrote the book on disaster robotics, and she is one of the founders of CRASA, the Center for Research and Search Robotics. I'm not certain if it's CRASA or CRASA. She's based at Texas A&M University, and she's got an amazing TED Talk. She was the person who took robots to the World Trade Center, and she is continuing, you know, they've been utilized in the Ebola issue in 2016, in COVID. She's been reporting a lot on the use of robots through COVID, but she's still continuing the wide range of search and rescue. And then you have a startup like Squishy Robotics from Alice Agagino at UC Berkeley. And she's doing a tensegrity robot, which is aimed to be dropped out of aircraft or off the top of buildings or what have you, to safely move through a disaster area. And if you're familiar with the tensegrity structure, then, or just look up Squishy Robotics.
That's interesting. And then the swarm robotics for, what would you call it? It's like search and rescue, where they would send the robots in, they would likely find people in report positions.
Yeah, we're not ready for swarms yet. I mean, the DARPA Sub-T Challenge, which the finals are going to be in November this year, but in the Sub-T Challenge, they were using, well, multi-robots. I wouldn't necessarily call it swarm either, but you know, some of them were the same sort of robot, to do things like leave communication infrastructure trails and to go ahead and do mapping in a range of locations and come back. So there's a new class of robots called marsupial robots. So it's super cool. And we're going to see marsupial robots before anything else. One of the reasons that we don't see swarm robots for search and rescue is that it's not what first responders want to deal with. They have so much to deal with. It's been tricky to first bring robots into the budget, and second, to make robots that are easily controllable. And who else has done some amazing work with that? Cindy Bethel. She was developing a 3D printable mobile camera that was able to be controlled through comparatively simple gesture controls for a first responder or some other controls. Because of course, if you're trying to send in a camera and you need to be completely quiet, you don't know what the situation is in there, you need to be on alert for anything that is happening around you.
Yeah.
The distractions. And indeed, you've touched on an area that is of great interest to me, because I think a large part of human factors work and human robot interaction, it started all the way back with the development of aircraft, it relates to filtering signals so that you only get the signals that are critical.
I work at ECM, so I'm familiar with that concept and how tough it is. It's much more difficult than people realize.
Absolutely. You've probably heard the story about iRobot's PackBot. Like, they sent the first ones into the army, and They opened up the suitcase of controllers, and the army people looked at that and said, come back when you've got an Xbox controller.
Yeah.
Are there any other questions?
Yeah, I have a question. Hi, I'm Thomas. I'm looking at your website, and can you talk a little bit? I was late. Maybe you talked about this already. Could you talk a little bit? And if you're repeating yourself, please, please excuse me for asking the same question. A little bit about the Silicon Valley Robotics Group.
Absolutely. Now, we were formed in 2010, before I came over from Australia, just by a group of robotics companies, including Willow Garage, NASA, Bosch, Adept, and approximately 30 robotics companies, SRI International in particular. And the key founding members were Willow Garage, Adept, Bosch, and SRI International. I came over and I was saying, why doesn't anybody know about robots in Silicon Valley? Like, this should be the real, like, this should be where things are happening, because we're going to start to get cheaper robot components, and we're going to start to get startups, and this is going to like boom. So the next thing you know, I'm actually, well, the first thing was organizing the Robot Block Party and actually forming Silicon Valley Robotics as an official organization. We formed as a 501c6 because we are literally a trade association. I sometimes second guess my decision, because if we were a 501c3, we might have been able to get grants, but we weren't. And so we have remained very true to the concept of an innovation hub. Our members, our vision was formed right at the start. It was to support innovation and commercialization in robotics technologies. So it can be any of the stacks: software, sensors, full stack robots, or just hardware. If you identify as a robotics company, or a company involved in robotics, but the point being innovation and commercialization. If you're purely about innovation, you're a research lab. If you're purely about commercialization, then you're a product line at a large company. You're not doing anything interesting. You're just, so we are looking after what is usually called the Valley of Death, the place where you don't get funding and it's very hard to survive. And one of the first things that we did was try to raise the profile of robotics in the Valley and increase the amount of investment. Now, in 2012, Amazon acquired Kiva Systems, and that was a real shot across the bows. Until then, most investors, barring a few that were already interested in robotics, would laugh at me when I'm saying, you're going to want to invest in robotics, And, but by 2015, I had major investors cold calling us to say, we've got a robotics and hardware division, and, do you want to talk to us about robotics? And I'm like, at this point, we no longer need to tell the investment community. In 2015, I worked out that there had been $1 billion globally invested in robotics, which was a figure that nobody believed, because that was really just unheard of. Now, in hindsight, it was more like $2 billion, and everybody is interested in investment in robotics. We've had a couple of billion-dollar acquisitions, for example, Cruise, the self-driving automotive company, being one of them, but we've also seen other acquisitions as well. Sadly, there is still a gap. There's a lot of seed funding in robotics now and some Series A funding. There is what we would call undervaluation in the Series B, Series C space, where most investors don't really realize. They see it as being an expensive type thing that doesn't scale as rapidly as software. They don't appreciate that you're putting in infrastructure effectively. You're putting in things that are going to create a much higher lock-in. And, you know, the investors that are familiar with robotics are far more interested. And there are now a number of funds that are robotics funds. They're even starting to specialize. So for example, brick and mortar VC, they don't look at it as robotics. They look at it as construction technologies, and they'll invest across the stack. And ditto some in agriculture and in other areas. And we've been trying a lot more to be connecting to the market area, because once you've gotten through that first maybe funding stages or so forth, your primary concern is getting to your market. And you're a very small team, so getting to market can be one of the hardest things. And that's what a good investor is supposed to help with. And that's what a university tech transfer team or accelerator is supposed to help with. And so we are effectively running an accelerator, only we don't invest and we don't take equity.
Have you looked at companies like Teradyne and Advantest and the prober companies that support semiconductor probe systems? Because they are right now mostly robotic, but they are what you would call simple robotics. That's why Cartesian robots with the rotationing systems in them.
Certainly, yeah. We have had some companies like Harmonic Drive as a member, ARM is a member of Silicon Valley Robotics, but we don't always find that companies, especially the large component companies, see the value. It's usually when they want to recruit in robotics or when they have a specific robotics R&D lab. When they just want to purchase robotics products, then they see more value in some trade shows. And they're a little bit blind to a lot of the innovation that's happening. Although these days a robotics company is just as likely to be showing up at a ProMat or a logistics trade show.
There's a group in JPL that works with robotics assemblies and examines what the potentials are.
Ooh, very interesting. Yeah, we have the intelligent robotics division up in Mountain View, Terry Fong's group. So they've been doing more complex space robotics generally, although I know there's also space robotics, of course, in most of NASA. So
I know JPL's pretty dated, so maybe they've outsourced it someplace else by now.
Well, there are so many different aspects of robotics. It's like, you know, they have more robotics divisions at NASA than one. Which I realized when I did a deeper dive into the NASA site. You know, their planetary rovers, for example, are robots, that's a different department. And as said, so I'm sure that there's a robotic assembly system department, as you pointed out. In fact, thanks for steering me to that.
They're looking into service robotics for the outside of the space stations to reduce the number of required spacewalks. So that's a specialized area for a multi-purpose robot.
Yes, I go up to, well, I used to go up to Canada, now I do it virtually, but there's a very cool university-based accelerator that has now incorporated robotics, specifically space robotics. And you might, there are now a lot of space robotics companies looking at providing things like space tugs. And, you know, it's very hard to know where the robotic part begins and ends, because they might be doing like a robotic furnace for fabrication or other tasks. And so often the robot part simply becomes the way that a task is done. It's not a robotics company per se, but certainly it's such an interesting growth area.
Okay, I'll shut up for a while, let somebody else talk.
Does a company need to live in the Silicon Valley to join your group?
We accept startups, you know, small companies from all over the world. It's kind of a case of, do you need access to Silicon Valley and our expertise? So we often find that startups around the seed Series A stage will join, whether they're based in Europe or Australia. And it's often because they're spending some time in Silicon Valley to fundraise. So we definitely see being a landing mat. We have some other global companies, like, for example, Harmonic Drive, or a large Japanese construction company. They're building a robot R&D group in the Bay Area, but they're very, we have an affiliate membership, which is primarily these kind of large companies that aren't necessarily robotics, but are interested. However, generally speaking, it's because people are doing robotics and want access to the Bay Area in some fashion. Or robotics component, technically.
Thank you. I lived in the Bay Area for 15 wonderful years, and then I found out I couldn't buy a house, so I moved down here to Southern Cal.
Oh, my kids might be joining that trend as well. I've had 2 in Los Angeles and 1 staying there.
All right. Speaking of investment, do you have any angel investors around, or is it just primarily the big investors?
I find it very hard to keep up with angel investors. I've worked, yeah. Angel investors try to stay pretty private, but by facilitating networking between startups, what you can do is you can find out, perhaps, you strike up friendships with some startups that have had angel investment, and they might share their investors with you. You can sometimes do a deep dive into funding figures to find the names of some of the angels, and then you can try and track them down. But usually there are people who say that they're angels that don't invest. They're enjoying I'm an angel investor. I've been an angel investor and it hasn't worked out terribly well for me. So I put a pause there. But yeah, usually the people that have got the big pocketbooks are pretty quiet about it. So it is definitely easier to track the venture funds, and there are a number that what you'd call micro VC funds or seed stage investors. So it used you don't necessarily have to go through an informal funding round before you get more formal investment. And if anybody's thinking about applying to accelerators, a lot of them are taking a big amount of equity compared to the benefits that they give you. I would recommend think very hard about if the benefits are worth it. And if you think they are, then negotiate terms. Most of them will drop the percentage of equity that they advertise.
Question, if I may. This is Brian. Through all that and all those various equity rounds, how do you protect intellectual property? I mean, it's about intellectual property. You've got a good invention. It's going to be worth billions, whatever. Do they just have casual little NDAs, or how do they do that?
Most investors don't do NDAs. An NDA isn't worth much when you have an idea. It starts to become interesting once you're getting your idea into the real world. And then it's actually more of a trade secret, although your investors like an IP strategy. Most investors won't sign an NDA themselves. It's something that after they invest in you, they want you to have an IP strategy. And that is much more to defend you against other companies. So if you think about it, individuals are rarely a threat to you commercially. Another company maybe. The biggest thing that you probably want to look out for is doing your own diligence on investors. Do they have a competitive company in their portfolio? Are they listening to you with rapt attention just so that they can learn everything about you and what you're doing, and then maybe pass those ideas on to their own portfolio company. So like always do your diligence about who you talk to, but don't be overprotective, because you're not going to be able to get the investment. You're not going to get the investors interested. And there's a real focus in the investment community on execution, rather than, it's like you need your IP strategy, but it's about, can you execute on your idea rather than not. They're like, there are hundreds of ideas in the universities. It's what we look for is that the combination of the really good idea with a team that can execute it at the right time. And the other thing is timing, being able to understand when and how the market is going to be ready to adopt your idea. And, you know, usually you're so busy focusing on those things, that's what puts you ahead 2 or 3 years. You will get copycats. Other investment firms, there's a couple that specialize in copying something that they see. And China does that as well.
How to protect against China, yeah.
Yeah, and there's a group in Germany that do the same thing. Good company. There's a couple of accelerators I can think about that do the same thing. Oh, one of them's out there. I think that's good, and we can launch it faster. So the point then is you've got to get to the go stage before you've really got anything to protect. And then once you hit that go, then the secret sauce is in how you've solved your problems to make it work, not necessarily what you're doing. And then your first customers and all of those things that keep you a couple of years ahead of your competition. And then it's a race.
Yeah. Audra, if I may, this is Forrest. I wanted to ask you, how would you prepare like young people today to take on the platform of what you're sort of broadcasting with robotics 4.0? What would you do to prepare them in that aspect?
In many ways, I think they're being prepared. They are playing games on tablets or smartphones. Minecraft is an incredible step towards, if they get to a little bit of the programming and sometimes just a sort of a three-dimensional model thinking. 3D printers are great if they're going to get into digital design, but there are so many different roles in robotics. I think the key thing is to let people know that robots are coming and that there's a whole range of roles for them within it. You don't have to be an electrical engineer to work in robotics. And this is one of the big things that I heard from many of the women in robotics, is that they would frequently say, well, I'm not really a roboticist. And I'm like, aren't you managing the research program for robotics for Intuitive Surgical? Well, yes, but my background's in health. You're managing a like massive robotics research program. I think you're in robotics. And, you know, we see this with people doing human robot interaction as well. We see it like so many disciplines have this tendency to think, well, isn't that other stuff robotics? Like I'm just doing this thing. And one of the big roles that companies have, like you've got these core robotics technologies that you're probably all familiar with, you know, comp sci, mech eng, electrical engineering, control systems, interaction design. That's 1/10 of a robotics company. The rest is product management, project management, operations management, sales and marketing, executive management, company management, financial management. all of these things are necessary for a robotics company. And I think we benefit by talking about the way robots can be used for social good. Because many people today go, well, if I can do anything I want what I do to count. I want it to be making the world a better place. And I think robotics offers us an incredible opportunity to be getting involved with technologies that make a difference. One of the things I like most about some of the robot competitions is the ones that is the focus on not just building robots and having fun, but researching how robots can be used to solve a problem in the real world. And the more that kids think about it that way, the more likely they are to see robotics as something that is going to have an impact that they can have an impact in.
Thank you.
This is Brian again. Can I pull you back to your Minecraft comment?
Yes, it didn't seem to sit well with you.
Oh, you saw that? Well, no, it was, I've got a couple of grandkids, little boys, 7 and 8. And you can't knock them off of the games.
Yeah.
They will sit there like vegetables all day. They even watch videos about somebody else playing Minecraft and Fortnite. And I'm thinking, well, maybe there's some good in it, but how do I guide them or nudge them to anything that is to the good versus the negative side of their eyes swirling while they sit there and vegetate?
One of the cool things about it is they're terribly creative. Usually, the kids that my nieces have all been hooked on it. As they've gotten into their teens, they grew out of it. But most of the time they are in the sandbox mode and they're building. It's the Lego for this generation, because what they do with Lego these days is they get the kit and they build that kit and then they put it on the shelf.
I've helped them do a few of those. Yeah, it sits there, the pieces are around.
Yeah, and each kit is so detailed that you need you want to get to that final construction. And that means that you build it as it was written in the kit. Whereas when I was a kid, my brother and I just had a big tub of bits and we could make whatever we wanted. We had to make whatever we wanted. It was a real treat if we got a little car or something like that. And then those pieces would be converted into other things, because that's what Lego was for us. It isn't anymore. But Minecraft is a whole lot of digital pieces that they build these incredible castles with. And then they start putting in booby traps so that people coming to visit can't get into their castle. And they start using redstone, I think it's called. And that's setting up, if this, then that. So you're doing basic logic in Minecraft. So it's not as bad as we think, and they will eventually grow out of it. So ask them how they can build booby traps and protect themselves and make their doorways secret so that it only opens when they come near it and not somebody else. And you might find that they start to introduce a lot of kind of coding. And I do think one of the big things is that, coding is frequently taught very well by graphical user interfaces that you can later convert into, pure code. But not everybody needs to convert to text-based code. For example, with robots, we're now doing so much more pose-based learning and graphical learning. So if you've got a modern robot arm, you're probably going to be able to use a sort of Blockly type graphical user interface to program it, or pose teaching. So we need to continue to move with the user interfaces.
I have to interject one thing here. I went through a whole bunch of stuff. I've been programming since probably 1979 or 78. And when I first started, I learned assembly language using a little book called Software Cookbook and Gourmet Guide. And really wonderful little book.
Mhm.
We don't have that anymore. We don't have simple books that take us through the steps to build really complex things. Because
Yeah,
complexity in general is the result of compounding simple devices. And somewhere we've lost that. And the visual programming is a terrible substitute because the complexity that has to exist to make that even work is not visible to anyone who uses it. And so they accomplish things, but they're restricted because the only things they can accomplish are things that have been done before. So the true innovative thinking doesn't come through from the graphical programming interfaces. And what you find is when you take them out of that environment and they try to progress further, it's very difficult for them to visualize how to take what they've learned and build something bigger, different, or better.
I've got two comments on that. And, you know, I agree with a lot of what you're saying, but I'll put the caveats that the range of options that we had with computing was far more limited than with robots that are moving in three-dimensional environment. And one of the biggest problems that we have is the incredibly steep learning curve with robots, where kind of every school robot team can learn how to make the robots move this way, that way, operate a sensor, blinky light kind of thing. But it's harder and harder to get past that, to start to do things that are productive. And this is where I think we're going to be, this is where a lot of the complex software today, I mean, software today is built using a lot of supportive architectures as well. Think of Ruby on Rails, think of the way in which we're using developer tools now to build software, where we're building on the work that other people have built. And we're lacking that in robotics. There are companies that are working on producing that. Some examples, you know, at a place space, Onki, before they folded, what they introduced was preset shortcodes that would allow you to get through some of that, like recognize XYZ, recognize face XYZ, recognize. So they put a lot more complex operations in where you were in control of the variables and how you put them together, but it allowed people to get to the more interesting things. Like now I can get facial recognition happening easily. I know I can program my robot to do something more cool when it sees me coming in, or if I say something or something else, instead of having to build my whole voice recognition, natural language processing library and so forth, I was able to utilize those things. But that was not transferable to other systems. And we're starting to see people addressing that at the moment. And I've just heard a really great talk from Rodney Brooks and Missy Cummings talking about how AI has failed robotics, because that is really perhaps the problem that needs to be solved.
Yeah, the DMNs are basically a large filter network.
Mm-hmm.
They don't really have intelligence built into them, although people have been sold on the idea that it's there. And machine learning has not made the leap that it needs to make yet in terms of what can be learned and taught and transferred. Google made some real huge steps, but they kind of rescinded some of it due to their bots that were on the, what was it, Twitter or whatever, where they were conversing with each other and eventually developed their own language.
Yeah.
To my mind, it thinks that we need somebody like Kernighan who could come along and write the C compiler, right?
Mhm.
Because that was such a leap forward in software compared to what went before. And then when he went into object-oriented programming, that was another huge step. It wasn't the best step. Even he thinks now that he didn't do quite the good job he thought he did. But we're looking at now with the things like, well, you mentioned Ruby on Rails, and then we have the data-centric languages that are replacing COBOL and Snowball and those kinds of languages.
Yeah.
And the difference of what we're doing now with data compared to SQL. And that now they have the no SQL interfaces.
Absolutely. So the developer toolbox is becoming very sophisticated. We're starting to see advances from machine learning for robotics, and I think DexNet is a great example of that, which is kicked off by Ken Goldberg at UC Berkeley and the Google Brain team. That's what they were putting their ARM farm on, and they were providing feedback every evening from 14 robot arms into the convolutional neural network, which was working on predicting a grasp strategy. And at the end of what was cumulatively, and of course, what was learned by one robot could be learned by all of them. And at the end of, I think, like 300,000 robot hours, they were starting to see the emergence of learnt grasping strategies, effectively hand-eye coordination.
Yes.
And that is the only way that you can develop grasping strategies for unseen objects. Otherwise, you're doing model-based learning, you're coding, you're effectively trying to predetermine what you're going to deal with, what grasps, what angles, and the rest. And retailers have, like Ocado has more than 54,000 objects. So you can imagine the computational load of trying to operate a system. It's just impossible to really deal with that sort of size of model-based system. So, you know, I think that's really promising, but we have to appreciate, as you said from the start, the actual complexity of, you know, these operations in the real world are vastly more complex than the comparatively huge advances that we made in image recognition and language recognition. You know, those are kind of two-dimensional. And now we're looking at four-dimensional, you know, over time, things that move, things that form as well. You know, we're starting to get things like grasping as a solved problem on rigid objects, and there's great strides on deformable, but these are still relatively constrained environment situations, you know, logistics, e-commerce. Now, I see I've occupied you all for a terribly long time. I knew there'd be great questions, but I'm going to have to call it a wrap if, unless there's some final questions. But I did
have one last question.
Mm-hmm.
Do you yourself build robots? And if so, what kind of robots do you build?
I build robots badly, and I am too impatient and too busy to spend a lot of time there. Arduino and Raspberry Pi have been fantastic. I've built a donkey car, and before that, when I came over, I did Maker Faire as a maker, and I had a couple of little, just really basic bots that responded to motion, actually, you know, not, but it would look like they were responding to people. And that's what I really wanted to do. I wanted to encourage people to interact with the bots. And so the moment you do something that goes whoosh, and it appears to be tracking, when you do something near it, what I found is it brought people in to play with them. And it was just to play with robots. I also played around with, I used a lot of feathers and sparkly things. I would have loved to have done one that was made of grass or other objects. I've done one that had, well, Guy Hoffman has been doing a knitted robot. And I really think that playing with the texture and the aesthetic appearance of robots opens it up to a whole lot of people who are otherwise just like, it's just like a boring computer type object to them. It just doesn't visually appeal to them. And I certainly found that my feathered robots that followed your hand attracted people that were otherwise just racing through the robot section at Maker Faire, trying to get out of there. So I think that that was an informal experiment, but I think it succeeded. And I think that helping individuals, we have roboticists in residence at Circuit Launch, and helping companies build robots allows me to get some of the vicarious thrill of seeing people building robots and feeling like I'm having some role in it. And as I said, you know, a little bit impatient to do it myself now. So I just, I do a lot of robot building vicariously.
Do you like humanoid robots? I have one off camera here.
I have very mixed feelings about humanoid robots. I think that we're going about designing them the wrong way, but I've tried to debate this with Ben Goertzel, and he is definitely of the people want humanoids. What can we do? We're going to build them. And it's like, yes, but one of my focuses is what kind of humanoids are we building? Like, barring Bina, who I think was involved in some of your activities, they're all white at the moment. What kind of message is that saying? And we're hard coding our biases about the gender, race, and appearance of robots. And if we then make those robots servants, we're perpetuating certain assumptions about who does what in society. And so that's why I have mixed feelings about humanoids. I do think that they serve a great companionship purpose. I do think we're going to have them. I don't think that they're evil, but I think that we need to deeply consider issues of race and gender and age and ability in terms of creating things that have too human an appearance. And so there's a little bit of a best practices around humanoid robots that not many people are kind of aware of or follow, but it is make it as little like a human as possible. Only add the human features that you need to add for the purpose of the robot. So a robot like Pepper was overdone a little bit when it comes to the hands, which are not terribly functional and terribly fragile. But the face was designed to be the face of a child rather than and to be a height that was non-threatening. And we've certainly seen with robot design that if you give your robot a voice, it better be able to listen and respond. Because if it speaks, everybody assumes that it's going to listen and respond. So we've seen many delivery robots where they didn't think it through, and they sent their robot out into the world and it says, here's your package. And then people tell it something. Yeah. That's, you've opened a can of worms there. That's a very interesting discussion, Thomas.
I suppose you're not interested in that Sophia robot then.
I love to hate Sophia. Like I said, I've debated Ben Goertzel on stage about whether or not we should have robots like Sophia. And you know, it's Sophia is a robot that doesn't epitomize the actual development of the state of art, doesn't really tell the world what robotics is capable of. Sophia generates a heck of a lot of ambushed headlines from people that then think that robots are going to take over the world and that that's what a robot is going to look like and what a robot is going to do. And they go, why? And I'm like, think of the aging populations. Think of our need for agricultural robots. Think of all of the amazing things that robots are going to do. And most of them are going to look like tractors. They're not going to look like a humanoid. That's the majority of robotics. Don't judge them all by Sophia, please. So.
And Sophia's basically a puppet as far as I can see.
Yes. Sophia is a theater performance, truthfully.
Oh,
A scripted theater performance.
I'm sure David Hansen would be very upset to hear me say that.
I think that they don't, I think that they admit it, but not to cameras per se. It's an illusion, like any good magic act.
interesting.
Yes, it is.
Hey,
Nice to meet you, Andrea.
thank you. It's been lovely meeting you all and talking, and I will say good night now.
All right. Miss Vicky,
Bye-bye.
Thank you.
Sandra.
Thank you.
Thank you for
Thank you
coming.
very much.
Thanks, Catherine. Thanks, Phil.
Okay, so,
Wow.
wow, she's dynamic.
Yeah, you hit a home run there,
Oh,
Kat.
she's got
Yeah.
interesting opinions. I'll say that.
Great. So I mean, her presentation touched on pretty much everything I'm constantly saying about robotics when it comes to commercialization, when it comes to environmental use, when it comes to making robots more productive in society. And also to incorporating the cultural studies in it. So by nature, I am my BS is in ethnic studies. And when I came into robotics, I saw this slope where you could intertwine robotics with ethnic studies. There is an area in robotics where you could look at it and people just don't, they turn away from it. And I love that she brought that into her presentation. So I thought that was really cool. Thank you, everybody, for tuning in tonight. I really appreciate it. The tech room appreciates it. So
Yep.
look forward to seeing you guys again on the 24th at 10 o'clock, I believe, Walter.
Yes.
10 a.m.
The morning.
Saturday.
Why the morning? So,
We used to have our meetings on Saturdays in the morning.
yeah. So 10 a.m. in the morning. We will see you on the 24th.
Nice to see you, Kathleen.
Well, what are we going to do on that Saturday? Is it a show and tell or another lecture?
Show and tell.
Show and tell. All right.
Works for me.
Anybody have a company that wants to join Silicon Valley Robotics?
Already
Don't know.
have, the Tech Apart has joined.
All right, cool.
Nice.
Okay.
Hmm.
Are we calling the end of the meeting or what's going on?
Yeah, we're gonna call it.
Okay.
Okay.
Thank
So
you.
yep.
Bye-bye, everybody.
Bye.
All right. See you later.
Bye.
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 See you guys at
See
the
you
next
later,
meeting.
Walter.
See
Stay
ya.
safe,
Dan,
everybody.
see you later.
Happy birthday, Tim.
That was a few days ago
I know.
Happy
but
belated
happy
birthday.
birthday.
on the 3rd. All right. See you guys later then.
Bye.
Bye,
Take care.
Forrest.
See you.
Les, you still there? No, I guess he's gone. All right.
Yeah.
See you guys later. Bye.
Yes.
Bye-bye.